Welcome back. In this lesson, we're going to look at plate tectonics. We're going to look at the shifting plates of the continents and the oceans, and how that they crash into each other, how they ride on top of each other and drop underneath each other, and all caused by serious stresses. We're going to look at some of the evidence that we see of where these things happen to be, and also some of the questions that this theory would answer. So let's look at some examples. We talked before how that people from various centuries had looked at maps and thought that the continents looked like that they had fit together. And Alfred Wegener, who spent his life trying to convince people that he believed that all of the world was broken up into these various pieces that fit together and were being pulled from each other and moving around. The problem that he had was that there wasn't an idea that would suggest how it was possible that plates could move together. Now, we saw also during the 20th century that as you measured the ocean more and you mapped the ocean, that there was evidence that the seafloors actually cracked along the inside of especially the Atlantic Ocean and other places, and that it's pulling apart from each other, and that you have the ocean floor moving towards, for instance, Europe and North America. And for that reason, there is much evidence that there's cracks in the crust and in the upper mantle that are called plates, and that these plates are in constant motion, moving around, and it's this motion that causes mountains. It's this motion that causes earthquakes. It's this motion that causes volcanoes. And that's how you can tell that you have a good theory, because it answers so many questions. One theory that suggests everything is diverse is how mountains are built, or why mountains would rise or fall, or how volcanoes work and earthquakes, and why there are trenches. All of these things are answered, or at least partially answered, by the theory of plate tectonics. And so it's widely accepted presently that that's what's actually happening. So the plates, there's 8 major plates, and there's some small plates too, and they're moving about a few millimeters a year. Not very big, not very fast, but over a long period of time, you can have, whole continents can move around. So you're going to see that because all of the Earth is full and these continents are moving, you've got some that are crashing together, others that are pulling apart, others still that are pulling together in one part and pulling apart in another part. So there's constant movement and friction and rubbing between these massive plates. And as you have you have rocks that are catching each other, almost like Velcro along the edges. And as pressures are built up, they can slip, and you can have volcanoes, you can have earthquakes, all numerous things caused by this. So the 3 major types of plate boundaries are diverging boundaries, where they're splitting apart, and we've already looked at this in section 2. This is the ocean ridges that are moving apart from each other and then being filled by the magma from underneath in the asthenosphere. You can also have converging, where they're crashing together. Now, to have 2 huge plates crash together, somebody's going to win. And so what happens is normally if you have an ocean crashing into a continent, the continent is not as dense as the ocean rocks, and so the ocean rock subducts underneath the crustal plate, or the crustal plate, and so the crustal plate rises up. Often you'll get mountains there. As the crust, as the oceanic crust in this case, would start melting as it gets hotter and deeper, it starts melting. That is what's causing the hot spots. That's melting rocks. That's how igneous rocks are formed, and it's also how volcanoes are formed. You can also have plates that ride sideways to each other, and that's called transform boundary. And it is earthquakes all along that area as it's grinding, and we're talking about miles of rock that's grinding into each other with huge, huge stresses and pressures, and that is what's causing earthquakes. So looking at a few of these independently, divergent simply means to go away from each other. Most of these are happening under the ocean. These are the ocean ridges, and this is the idea of seafloor spreading. But there is one notable exception, and that is in East Africa. You've got an enormous rift valley where essentially a gap is being dropped into the middle of this plains. This is near Kilimanjaro. So the eastern side is in one plate, the western side's in another plate, and it's moving away from each other. And so what's happening is you actually don't have water to cover this, and so you can see the effects of this rift. And rift meaning actually rip. The ground actually rips apart. It's pretty scary. When you have a convergent plate, you have subduction, and that's a word nobody uses very much. It's the idea that one plate has to ride up on top of the other is dropping down below the other. And so it's a car crash, but rather than simply rumpling up, one is being forced at high stress, high force, to actually go underneath the other. In a case of an oceanic crust, where they're both about the same, right? You're going to, one of course will go down underneath the other, and that is where you're going to get a trench. So the Marianas Trench, for instance, is in the ocean off of the coast of East Asia. And so you can also get, for the very same reason, you're going to get volcanoes there, because as this oceanic crust is melting, that hot molten rock is going to rise in the lithosphere, in the asthenosphere, and actually cause magma chambers. So if you were to have an oceanic continental crust, usually you're going to have the oceanic crust subduct under the continental crust. In the case of a continental, the only one I'm familiar with, I'm sure there's others, is India has crashed into Asia, and that's what's caused the mountains. So the highest mountains in the world are caused because both of these types of rocks are the same density. So you have continental crust crashing into other continental crust, but not riding lower. They're riding at the same level, and so essentially you've got a car crash. And it's this rumpling of these two continental crusts that are causing these high mountains. So especially the Himalayas. The Himalayas in Nepal are thought to be caused by the whole continent of India, a subcontinent of India, crashing in to the lower edge of Asia. And then lastly, transform boundaries. That's where we would know, say in California, this would be a fault line, and you would have, for instance, the coast of California going north and the inside of right into the coast going south. So right around Los Angeles, San Francisco area, and this is what's causing these major repeated earthquakes over the centuries in that area.